Hi, so we're going to continue to talk about operator overloading for user-defined types. And in this video, we are going to talk about the comparison operators, such as less than. So while there isn't a standard or a formal definition of less than operations between kind of vectors, one fairly commonly used definition is to compare the magnitude of the vectors. Now, the magnitude of a vector is its length. So it doesn't really care about the direction the vector is pointing. It just tells us how long the vector is. So mathematically speaking, it actually has the same meaning as the absolute value of a number. And if you remember what absolute value is, so it's just how big the number is, regardless if it's positive or negative, right? So that's why um, um, absolute value also kind of just means magnitude. So now the magnitude of a vector is the square root of its x component square plus the y component square. So square root of the sum of these two. Okay, and in as far as Python goes, you probably seen this before. The ABS built-in function, we typically use that to get the absolute value of a number, and the ABS built-in function actually calls an object's under ABS method. So to show that to you, so ABS minus 1, that gives us a 1, right? Now ABS of minus 1 is the same as the integer of minus 1 dot dunder ABS. So if I call that, that also gives us a 1. So what this means then is we should define the dunder ABS method for our vector class, which I've done here. So I defined the dunder ABS for vector, and that's basically just, again, x squared plus y squared, and we square root the sum. So to use it, I just call ABS on the vector, and if I run that, that should give us for the vector 3 and 4, the magnitude is 5. Now, once we've defined the magnitude or the absolute value of a vector, then we can use it to define the less than operator for the vector. Now, for less than the operator, the corresponding dunder method is dunder LT, which stands for less than. And all we have to do, and when we do, compare two vectors, um, I hope you get the drill by now that the first vector is going to be assigned to self, and the second vector is going to be assigned to other. And all we have to do, because we want to compare the magnitude of these two vectors, so we take the absolute value of self, the first vector, and compare it with the absolute value or the magnitude of the second vector, the other. And that's all we have to do. So I've typed it out here. And this is the print statement. And so the vector 1 and 2 is definitely has a smaller magnitude than the vector 5 and 6. So it is less than. V1 is less than V2. So now I'm going to ask you to define the greater than operator for the vector class. So a vector is greater than another vector if the magnitude is bigger, right? And the corresponding dunder method for the greater than operator is the dunder GT method. So pause the video and give this a try, please. So, okay, hopefully you've done it. And here is my answer. So there are actually a couple ways to do it. One is to simply do exactly what the dunder LT does and just flip the comparison sign. right? So let's run this. The vector, the v1 is not greater than vector 2, so this should give us false, and so that's good. Now there is another way to write it, and I actually prefer this second way to do it, and that is, instead of explicitly comparing the magnitude again, it recognizes the fact that self greater than other means the same thing as other less than self, right? And because the other, we expect it to be a vector, and we already defined the less than method, and that would actually be this. So we are simply calling, we're simply flipping the greater than operation into a less than operation. So in that way, it should also give us exactly the same result. And that's what this slide says. And there is actually a third way of writing dunder greater than, and that is by doing nothing, by just not even writing it. And that still works. And I believe the reason that works is because it's similar reason to the way that the regular multiply and the reverse multiply works. That when Python sees, okay, v1 greater than v2, however, for v1, the vector, the greater than method is not defined, then it actually looks at v2 and see that it's a vector, and because v2 is a second operand, it knows to try to find the dunder less than method, which is exactly what we did here. So Python knows to automatically invoke that, but with v2 now just assigned to self and v1 assigned to other, and that's why that without writing the dunder greater than, um, this greater than comparison works. And that's what this slide says. Now, very interestingly, though, that if we try to do something like less than or equal to, we would expect that to work, right? Because we've already defined less than, and we've defined the dunder equal. So less than or equal to, it should be just, I would expect Python to be able to do this or that, and automatically do it. However, if you run it, it doesn't do it. It says it's not supported. This less than or equal to is not supported between instances of vector and vector, which is a little disappointing. So I have not dug into the reason why Python doesn't automatically do this. There's probably some math or logic reason to that. But then, okay, how can we support it? Well, it would be fairly straightforward. We can define the dunder LE method, which is less than or equal to, right? And we can just say, it returns self less than other, or self equal the other, right? That's the meaning of less than or equal to. But there is another way to do it. So if we think a little more carefully about what we already have, that we already have the dunder equal and dunder less than, then we human beings, and also Python, should be able to infer all the other ways that we want to compare the vector class instances, right? Such as greater than, we already saw that. Less than or equal to, it should be able to do that. Greater than equal to, it also should be able to do that, right? With just these two methods already defined. So as a matter of fact, it can, if we explicitly tell Python to do it by using this decorator called the total ordering. So we can decorate the class vector with total ordering. And once we do that, and assuming, of course, that we have the dunder equal and dunder less than method defined, it would create the rest of the comparison dunder methods, such as less than or equal to, which used to not work for us, but now it does. Now, if we are missing one of the dunder equal dunder LT method, let's say if I comment this out, then it would complain because the well, total ordering would complain because it wants at least one of these comparison operators. So if you see this error, I mean, obviously you can define dunder LT like what we did here. You can also define kind of dunder greater than or dunder less than equal to, and all of these would kind of provide um, enough information for Python to infer all the rest of the comparison operators. So what are the useful thing we can do now that we have both the dunder equal and dunder less than method defined? Well, we can now sort all the vectors, obviously by their magnitude, because that's what the less than method is comparing. And we can sort it by using a built-in sorted function. Okay, so so I've already kind of written the code out here that I have a list of vectors, these three vectors, and it's probably hopefully pretty obvious that this one has the smallest magnitude, this one has the longest, and this one is in the middle. So they are unsorted right now. And I print them out. Now, I think most of you probably not familiar with the syntax. Don't worry about it right now. All that is doing it's unpacking the list of vectors so they become individual vectors. So you will see three vectors printed out, and then I call the sorted function to sort this list of vectors and assign this sorted list to a different name, and then I print it out again. So let me run this, and there we go. The unsorted one was the original one, right? And then the sorted one, now the vector with the smallest magnitude is the first item. With the second shortest magnitude vector is in the middle, and then the vector with the largest magnitude is the last one. So it is sorted. And the reason, again, that the vectors can now be sorted is because we define the dunder less than method. So so given any two vectors, we know which one is smaller and which one is larger, right? We also define the dunder equal method. So given two vectors, we can check if they are the same or different. So with just these two methods, the vectors, any list of vectors can be compared and sorted. Now, just want to point out, this does not require total ordering, so I can take out total ordering and this would still work. Okay, so all we need again is just the dunder equal and dunder less than. Now, if I comment out one of them, then it's not going to work because, well, the sorted function is specifically looks for the dunder less than or the less than operation between the instances of vector and vector, because well, that's what's in this list. So now I'd like you to practice writing comparison operators for this very simple car definition, which it just has two attributes, the make and a model. So the two car instances, they are equal if the make attribute and the model attributes are equal. And one car is less than the other if the make attribute is less, and because the make attribute is a string, so you can compare two strings if one string is less than the other. Now, if the make attribute of the two cars, if they are exactly the same, then we can compare the model attribute. And I would like you to instantiate a list of cars and make sure that you can sort it. And when they are sorted, it is first sorted by the make, and if the make are the same, then it's sorted by the model. So please pause the video, give this a try. I did not write the answer keys for this, but if you have questions, feel free to ask. So one more operator that we have to talk about for this topic is the assignment operator, the single equal sign. So can we overload the assignment operator? Well, the answer is absolutely not. The assignment operator in Python, what it does is always to associate a name with a reference to an object. So, and it is so fundamental to how Python works that Python does not allow it to be redefined or overloaded. And that is in contrast to some other languages such as C++ that you can actually overload the assignment operator, but not in Python. So as a summary for what we've been studying for a few videos now, that regardless of what type it is, whether it's a built-in type or a user-defined types, Python allows any type to use its kind of a rich and very standard and special syntax if these types just define the right dunder methods, right? So what this does from the perspective of the client code that uses these types is that the client code can use very simple syntax, very familiar syntax to utilize these classes. Now, what this provides for the classes, and especially the user-defined classes, is that the user-defined classes now have the same access to these simple or special syntax as just the built-in type. So, so this really gives them a lot of flexibility as well as a lot of powers. And I hope that you are convinced after seeing the examples that we've gone through. Now, do know that what we just studied is really a very small subset of this particular feature of the Python language. And if you look at the official documentation about Python's data model at the link that I provide, it is a very long document and it has a ton of details. Now, I don't expect you to read through this documentation. I did not myself, but the hope is that now that you know how it works, one day if you need to do something, then you will be able to look it up, be able to understand it, and be able to use it to achieve what you want to achieve.